Let's go. Time for mine. No time to TikTok your stuff. All right, so today, functions. Just a general overview of functions.
I love functions.
Yeah, everything in life is a function almost, so let's start with it. Basic information. Every x or input, remember those two are interchangeable, there is only one output. So here's a logical saying. You come work for me, I'm paying you $10 an hour, right? You come work 1 hour, you get $10. That's a function. But if I say you work 1 hour and it's $10, but then again it's $5, that's not a function. Because at this one x value, I can't have two dots up here. Okay, that's not a function. Alright, they relate to things, like I just said, hours, pay, stuff like that. So we can make numerous examples, that's just the most common. Like I said, they can be anything, connect them. Hours and money, it's probably what I'm going to use for your example today. So, let's get it. So you have, first of all, the situation is $25 per hour. Okay, pretty cut and dry. In function form, we would have f of x equals 25x, where x is the number of hours, and the output y is the amount of money or pay you get. Well, in a function, it's no longer y equals stuff. It becomes letters that actually mean something. Like pay, your pay, letter P, is dependent on how many hours you work. So, H is the independent variable and the pay is the dependent. Because the number of hours you work dictates how much money you get. So we have pay dependent on hours is equal to $25 times every hour. So now we're just going to pick some hours, let you all pick and tell us what to use, and we're going to make a table. So I'm going to go with the easy one. You work 0 hours, you get $0. Lazy man.
That's what you got to do.
Anybody out there, any requests? -2? No, that don't work. No, there's no -2 hours.
No such thing as negative time, right?
So what number we want?
Let's do 3.
3. All right. 3 hours is $1, 2, 3, $25. All right. Anybody? And any number we pick, let's say 5. This is your slope, right? If you can't keep up or it's not going each time up by the same, we can plug 5 in here using function notation. So if I want to know what 5 hours, I can go 25 times 5. So at 5 hours, H here, we can get $125.
Ooh.
And we could keep plugging in numbers, or we could keep going with the slope and go up 1. So each hour we're getting another 25. And just keep the pattern and not really have to think about it much. So today's slides, we're going to be taking a function, a table, graphing it, and putting words with it. Because if you're given any of those 4 situations, you need to be able to go back and forth between all of them, especially this year. And everything today is going to be linear based. So I think I got that small up there. At the football game, they expect that every 4 people who attend will buy 3 hot dogs. So 3 hot dogs.
Okay, so you want to do the equation first, table, or you want to graph it first? What do you guys think?
That sucks.
That sounds like. So, for every 4 people who attend, the concession stand will sell 3 hot dogs. So, if there are 0 people in attendance, what do you think's going to happen? 0.
Damn.
Okay, so next one, we got 400 people. So for every 4, we're going to, sell 3 hot dogs. Take it over, Greg.
Well, normally that'd be 4 and 3. Well, they jump straight at the 400.
Whoa.
Well, if that's 100 times, well, this should be scaled the same, so that should be 300. So it's still keeping that 4 to 3 ratio. So here, if that doubled, what should this do? Not triple. Shut up back there. It should double. Yeah. There's always the class clown. changing up stuff, doing weird things. Again, it's adding 400 here. It added 400 there. So I think this table is going up by 400s here. So over here, we should be going up by 300s. So it's not your average beginner one. I like to give you more abstract numbers, bigger. So if we simplify that 400 over 300, what is our slope going to be? 3/4?
300 over 400, well, that can simplify. Hopefully we can see 2 3/4.
So when you're writing a function, we want to use letters that make sense. So the attendance and the number of hot dogs. So the people that come to the game will tell us how many hot dogs are sold. So the hot dogs are dependent on the people in attendance. And again, our slope's what we want next. So 3/4 A. So every 3/4 of a person, there's a hot dog sold. Dang, that's going to be hard to do. And there's no y-intercept, so we're starting at 0, so 0, 0. So if we go to graph this, we're going to start on our y-axis and the x-axis, which I'll just go ahead and make it red, at 0, 0. Well, I don't have much room here on this, so I'm going to kind of go up by these numbers, what my slope should be, rise over run. So we're getting, well, I jumped the gun. I got to label things, so you don't know what I'm doing. So the attendance, so this is the number of people attending, and this is the number of hot dogs for your X and Y. That's a horrible D. So we're increasing every 3 people, there's 4 hot dogs. Is it every 4 people, there's 3 hot dogs? Think about that. I'll give you a second to do it, and we're going to answer it. So to help you change in Y, we're changing X. So it's 3, 4. 3 hot dogs for every 4 people. So I'm just going to go by 4s and 3s. Put a point there, put a point here. If I keep this nice pattern, just using my slope, they all should fit. Make a straight line. And there we go. So if I give you just this, you should be able to make the other 3. That's the goal today. If I give you this, you should be able to make the other 3. It's kind of what we're doing here with these flip charts, and we only got a few more.
Notice that the graph, too, it's constantly going up. There's not going to be a negative attendance. So there's not going to be negative numbers over here in attendance. And obviously you can't sell negative hot dogs either, right? Just something to think about.
Awesome. Here we go. New situation. Well, we're going to start with...
So we got our graph over here, miles traveled versus hours. So it's looking like for every 2 hours, we've traveled 100 miles. 4 hours, we've traveled 200 miles. I'm not too good at math, but I think I can kind of start to see that if I'm going 100 miles in 2 hours, then I'm probably only going 50 miles in 1 hour, right? Right? We see that? So we can go ahead and write that. Can you guys see that possibly?
I did it backwards.
Okay. So again, our y's is our 100 over our 2. So that's about 50 miles per 1 hour. So if we want to go ahead and write that up here in our equation, we want to call it, you can call it y equals, or you can change it to x. It can also be written as, let's see, miles would be our y, and hours would be our x. So we can also write that as miles each 50 each. Might be kind of hard to see. So there's our equation. And now we can go over here and start filling our table. Looks like Mr. Greg's already got a few of them. For 0 hours, we traveled, obviously, 0 miles. 1 hour, we traveled 50. 2, we traveled 100. We can also just continue to look at our graph. You can see that for the next one would be 3 hours. Well, we've traveled about 150 miles. You Probably can see the pattern. We're going up by 50 each time for our miles traveled. Probably can see we're going up by 1 each time in our hours. Right? We want you guys to see that all of these are connected. We have to be able to kind of jump from equation to the table, from the table to the graph. It's all connected. And we can see it just continues to go up 50. Our miles are going up by 50 as our hours are increasing by 1. Right?
The next part is creating a verbal situation. So can you sum this up in words? So
basically what we've just been saying, right? So you want to write it out?
Sure.
Of course.
Oh, my bad.
I didn't know if you wanted me to or if you wanted to.
Every hour, what's going on? So every hour,
we're traveling 50 miles.
We travel an additional 50 miles.
Right? And that's all we're looking for description. It's just basically being able to say or write what is going on in the situation.
I'm abbreviating, yeah. So that's it. Can you sum up what you see into words? All right. Got a few more examples. Go ahead and try these next one here on your own.
Click pause. See if you can fill each of these out.
We'll wait on you.
Did y'all finish it?
Oh, we didn't stop.
Man, that was fast.
Mario's plumbing service charges $40 to make a house call. So he calls me. I'm already giving $40 if I just show up over there. I ain't done nothing. If it fixes itself, he still owes me $40 because I came. I saw I want money. So at 0 hours, just starting, we're at $40. I've not even done anything. So that's our y-intercept. So on this graph over here, we'll have to go to 40, but we'll talk about that in a second. Then after that, we'll charge him $25 an hour. So after 1 hour, that's going to go up an additional 25. And as that goes up an hour each time, this is going to go up another 25. And 165.
Oh, yeah.
So my function, go ahead.
So if we're going to graph these points that we've just found, right? So obviously at 0 for our hours, that's kind of hard to see down here. We got 0 hours, and it's going to go up. He's going to make $40. I guess we can go up by, we'll call this 20, call that 40, right? So at 0, we're at 40. So 60, 80. I'm not going to write it all out, but oh, there we go. There we go. Nice. Okay, so 20, 40, 60, 80. So after 1 hour, we're at 65. So just right above there, somewhere in there. You can be approximate. After 2 hours, he's going to make $90. So right here in the middle, right? After 3 hours, it's a lot harder than it looks to get it onto this graph. But after 3 hours, boom, it's going to be somewhere right in here. We're being nice and approximated. But you guys should kind of at least get the gist of what the graph's going to look like. Right? It's rising. Obviously, it's all positive. We have our X and Y.
And always make sure you practice labeling your axis. We ran out of room here because I'm just confined to my board. So hours, and this over here is going to be your money, how much you're charging. So make sure you always label that. And last thing, the function.
Our equation here, so if you want to go with y equals, looks like we've used X and Y or hours in charge. We've got our y equals, it's 25 an hour, so we can call it 25x or 25h plus 40. Let's see, if we want to put it in our function form, you could say that we're doing, what, an h?
We can call H for hours, C for charge.
So H and C equals, let's see, 25 for the charge, I guess.
All right. I always have him do this. So, is there a mistake? No. Yeah, maybe. So the H is perfect. That's perfect. So is the hours dependent on the charge? And this is where I screw up too occasionally. He did it on purpose for me. So the charge, how much you get, depends on the
There
hours.
we go.
The screen's going black, sorry. But, yeah, the Y value, your X. X is always the little part here because it's going to dictate what that is. So we got one more example, I believe. Maybe two. Two. All right, try this one, hit pause. And we'll play Jeopardy music in our heads. But, okay, you've had time. We're going to fly through this one. So I'm going to start by labeling the axis because I haven't done that too much. I need to pay attention to that. So X is my pumpkins, Y is my pounds. So I'm going to call this pounds over here. Call this pumpkins down here. So the number of pumps. So they've given me the points. All I have to do is graph it. This is going by 5s. This is going by 8s. So then I can just make that my scale over here. So my pounds are going up by 8. So I'm going to go 8, 16, 24, 5, 10, 15. They normally don't do that, but I'm limited here, so that's what I'm going to do. So all I got to do is put those points. It's going to look like a perfect straight line forever and ever. So now, can we sum up what's going on? Well, we started with no pumpkins, no weight, so I don't have to worry about that. So mostly I want you to tell us the slope here. And Coach Ramsey will go ahead and fill in that for us while I'm explaining this. We're going up 8 pounds every 5 pumpkins. So 8 pounds every 5 pumpkins. But is that very useful? Not really. We normally want to know what is it per pumpkin for each one pumpkin. So what do I need to do here? Yeah, that's right, little Billy. We're going to divide them, right? 8 pounds and 5 pumpkins. So 8 divided by 5 is 1.6. So we're getting each pumpkin is 1.6 pounds. So it's 1.6 pounds per pumpkin, or 8/5. So from this one little table, we should be able to create all this information and understand it. That's the goal. And our last example, it will make it yet, is a parking garage.
Okay, so at the North Parking Garage, it costs $5 to bring your car into the garage, plus $2 for every hour the car is parked, right? So if we want to start at our table, right? Well, if we're in there for 0 hours, it's still going to cost us $5 because just for entering this garage, it costs $5, right? So our initial charge of $5. If we're in there for 1 hour, well, that's 1 hour, so $5 plus $2 per hour, so that's going to be $7. If we're in there for 2 hours, well, 2 times 2 is 4, plus the initial cost of $5, so that's $9. You guys are probably picking up on the pattern here, right? For 3 hours, it's going to be 11. For 4 hours, it's going to be 13. For 5 hours, it's going to be 15, right? So we can see that each charge, it's going up by 2 each time, so on and so forth, as our hours are increasing by 1, right? So $2 is going up for the charge, $1 each hour, or 1 hour at a time, sorry.
Right.
Now if we want to go ahead and graph, this one's a little easier to graph. At 0, we'll go by 2, so there's 2, 4, 6, change colors on it, 8, 10, 12,
I'm
14,
kind of annoying.
right? So for 0 hours, we still said that it's going to cost us $5. What color are we at now?
Whatever you want to do.
0, 5. And for 1 hour, we were getting charged $7. For 2 hours, getting charged $9. You guys can see the pattern. It kind of keeps going here. Hopefully we're getting the hang of it by now. Right?
Awesome. Well, he wrote the function last time. I'm going to take his this time. So we got charge and hours. So total they charge me depends on them hours. Well, we have $2 per hour, correct?
Yes, $2 per hour
And
plus our flat rate $5 charge.
Awesome. So we might give you another one. One more. I'll do this one. All right, we got tree height in feet and year. So there's my Y, there's my X. So we're going up by 2s here. Oh, 2, 4, 10. Oh, that went crazy. I'm only going to go through the first 3 just for the graph. So there's my axis. 2, 4. That's 2 and 4. This is going to be my years because the years is the independent variable. The years are going to tell me how tall it is. They dictate that. And we start at 8. 4. Yeah, we'll go by 2s. 4, 6, 8, 10, 12.
How's y'all's Google Classrooms coming along?
Yeah, there's our lovely principal while we're making our video. We're doing good.
Say hi. Say hi.
Yeah, you keep working though. Alright, so we're going by 2s here on the height each year. At least that's what it looks like. So it went up 2 feet every 2 years. Well, the slope's not 2, it's 2 over 2, so it's going up 1 foot every year. So the height, depending on years, is going up 1, and it starts at 8 feet. So whatever the year is, that's how much we're adding to it. It's pretty much going up 1 a year. And we could write that here as the description. So to finish the graphing, we're at 0, 8. Then we're at 2, 10. So at 2, go up to 10. Boom. And then 4 is 12. And we can keep that pattern for as many years as we want. If I ask you what it is in 500 years, can you find that time, or how tall it'll be in 500 years? Okay, 500 years up. Take 500 and just plug it in. Since it's a year, put 500 there. So 500 over here, because you don't really want to graph that on and on.
It'll take you a little while.
I've seen it happen. I'm like, come on, dude, let's practice this. So 508 is how tall it'll be in 500 years. So that is it for today's lesson, but we want to show you something. I always do.
I like these cool shirts. We're mathletes from Copco. Shout out to my girlfriend Sadie for making us these fancy shirts.
It's so comfy. It makes me look buff.
We're mathletes.
Yeah.
What can we say?
Toss it up. Woo! Time to go. Have a good day.